Hello viewers, we are learning today what is the electrophilic substitution reaction. Okay?
Yes, sir.
Let us start now. First of all, we have to know what is an electrophile. Look at the word electrophile. It is constituted of two parts. One is electro and another is phile. So what is electro? Electro means electron or negative charge. Okay?
Yes.
That means if a species carry one or more electron, it will be converted to a negative ion. For example, the negative ions may be Cl minus, etc. Now, what is phile? Phile means affinity or love towards a negative charge. So, itself will be a positive charge that is represented by E plus. Is that right?
Yes.
What are the examples of electrophile? Nitrogen cation, Cl plus. Now come to the point, a neutral species will also be an electrophile. For example, sulfur dioxide. If we draw the structure of sulfur dioxide, look, there is 3 pi bonds. Is that right?
Yes, sir.
So, an electrophile would be either a positive charge or a neutral species. If it is positive charge, it should carry a vacant orbital. Is it right?
Yes.
Again, if it is a neutral species, it should carry at least one pi bond which can be broken during the electrophilic substitution reaction. Is it alright?
Yes, okay.
How? In this way. It vacates the orbital on the central sulfur atom. Is it right?
Yes.
Another example of electrophile that carries positive charge is alkene carbocation. It may be primary, it may be secondary, or it may be tertiary, not quaternary. Is it right?
Yeah.
Example of primary carbocation, it may be methyl, ethyl, propyl, butyl, etc. etc. For secondary carbocation, I am drawing one example here. This is isopropyl carbocation, we know.
Yes.
There are tertiary carbocation, and if there is a tertiary carbocation like tertiary butyl carbocation, in short we write D-butyl. Okay?
Yes.
So now, come to an example of electrophysics substitution reaction, taking the example, general example E plus, and the reactant is here benzene. So I can clean the board.
Okay, sir.
This is the structure of benzene.
Yes.
Are you sure this structure of benzene is alright? Yes or no?
Yes.
No.
Why?
Because to explain the reaction mechanism, we take it as this structure. The actual structure of benzene according to molecular orbital theory is like this. Okay?
Okay.
We are explaining this according to valency bond theory. Actually, the resonance idea is a vague idea in chemistry. You know?
Yes, sir.
But we are bound to use the resonance structures or canonical forms of benzene and other so many examples to explain the reaction mechanism on. Okay? So now come to the point. Here is an example of electrophilic substitution reaction taking E plus and electrophile. This bond will break and attack on electrophile because electrophile is an electron deficient species
Yes.
which carries a vacant orbital that can accept the electron pair of this pi bond. Okay?
Yeah.
Therefore, that leads to the intermediate is all right, the structure.
Yes.
Look at this structure. There are two pi bonds.
Yes.
Here it is a vacant orbital which carries a positive charge. It is also called carbocation. Now here are four bonds, two carbon-carbon bonds and one carbon electrophile bond and another is carbon hydrogen bond. This is also called sigma complex. Sigma complex is written like this because it can go through the resonance like this. Okay?
Yeah.
This is the sigma complex. But to explain the reaction mechanism, we need not to use sigma complex, but this is a fact. Because this carbocation is stabilized through resonance and forms a resonance hybrid which is called sigma complex. Is it alright?
Yeah.
The final step of the reaction. This bond will come here. Here one thing is to be discussed. Is there aromaticity present in the sigma complex? Yes or no?
Lost.
Aromaticity is lost. So it must regain the aromaticity.
Electricity again.
So to regain the aromaticity, the proton had to leave. Is it alright?
Yes.
So in this way, proton leaves the system and there is a formation of pi bond here. By this way, electrophile has been incorporated in the benzene nucleus. Is it alright?
Yes, sir.
So this is not a compound. It is an intermediate. During the reaction process, benzene at first takes the electrophile
Yes.
and produces the intermediate, which is of higher energy than benzene. Is it alright?
Yep.
And as there is no aromaticity, and we know an aromatic system is very, very stable, so compared to this intermediate, so it must regain the aromaticity and leads to the product which carry the electrophile.
Yes.
Okay? So I am taking now other examples, actual examples. That means the reaction of benzene with electrophiles. First of all, we'll explain what is the correlation of benzene, how it happens. Look at the structures. This bond will attack the Cl plus. How Cl plus is then generated? PUE, anhydrous aluminum chloride, and then catalyst, which generates the bonding electron pair of Cl-Cl bond attacks the vacuum orbital of aluminium. Is it alright?
Yes.
That leads to the ion pair LCl4 minus
And Cl plus.
and Cl plus. Very good. So here not only present Cl plus, which is
AlCl4 minus is also present.
LCl4 minus is also present near the
Cl plus.
Cl plus. Very good. This is an ion pair.
Yes.
Okay? This is the intermediate.
Yes.
Is it alright?
Yes.
Yes, base lump.
Yeah.
It takes up a proton. And this one comes to here. That leads to the product. And another aluminum chloride will back. Okay? And there will be another product HCl.
HCl.
And the main product is chlorine. Is it alright?
Yes.
Benzene reacts with chlorinium cation.
Yeah.
Chlorinium cation incorporated in the intermediate. Proton leaves and
Gives the product.
proton
chlorine.
goes with HCl for minus.
Yes.
That leads to HCl and NCl3.
Yeah.
Okay?
Yeah.
And chlorobenzene will be the main product. So this is all about chlorination of benzene. I am taking now nitration of benzene. You can see this is a nitrogen cation. It's a linear structure, and it carries positive charge on nitrogen atom.
Yes.
And it carries two pi bonds. Okay? Now, this pi bond will attack on nitrogen atom, and nitrogen atom, from nitrogen atom on pi bond comes towards oxygen because oxygen is more electric than nitrogen. So the pi bond breaks towards oxygen and packets the orbital on nitrogen atom, which accepts the one electron pair of benzene, which is broken during the process. As previous. Okay?
Yeah.
Okay?
The pi bonds.
Is it alright?
Yes.
Okay, it's alright?
Yes.
Because benzene at first reacts with nitrogen cation, is incorporated in the benzene ring, H plus leaves from the system, and this is the product nitrogen. Is it alright?
Yes.
We have discussed earlier, this is the first step, this is the formation of sigma complex. I am not repeating here. Okay?
Yeah.
Sigma complex attempts the aromaticity and forms nitrobenzene, leaving behind a proton in the system, in the process. Is it alright?
Yes.
This is all about nitration of benzene. Okay? We'll discuss about now sulfonation of benzene. Okay? Is it alright?
Yes.
Pi bond on benzene attacks on sulfur, the central atom, which carries 3 pi bonds. One of 3 pi bonds will be broken towards oxygen,
Yes.
and the oxygen atom will be negatively charged. Okay? That leads to the intermediate, which we have called as sigma complex. Now, look at the figure. This O minus, that means the electron pair on oxygen atom will attack on this proton, and the bond will be, the CH bond will be broken towards the carbocation, and the aromaticity will be regained, and the product will be benzene sulfonic acid. Okay?
Yes.
Benzene
Sulfonic acid.
sulfonic acid. Okay. This is all about today's class. In next class, I discuss about Friedrich reaction. I will be in the next class with you, starting from electrophoretic substitution reaction with the example of Friedrich reaction. That means alkylation and acylation of benzene. Thank you.
Dear students, I know PS sir for more than 30 years. He was one of the best teachers that were there in the locality, and he was extremely loved by his students as well as by parents, and he was always committed to providing best education. He is also an excellent teacher who explains very complex topics very nicely, everybody can understand. He changes his teaching method depending upon the need of the student. That's an extremely good quality, and I'm very glad that he has decided to continue teaching even during his retirement through his Poulomi coaching center. So I recommend all of you who needs additional help, please reach out to Poulomi coaching center, and there is provision for economically poor people also to get the free education from the Poulomi coaching center. So extremely highly from right way I recommend students for Poulomi coaching center.